Hi everyone, I am Bharat Singla and welcome to Learn Competitive Programming with CodeChef. This channel is a one-stop destination for you if you want to master CP. Here you can easily learn data structures and algorithms by just attending the live sessions that our educators take or by watching these video editorials. So if you are new to the channel, consider subscribing and turn on the bell notifications. Great, so now let's get started. So hi guys, I am back with another problem and the name is team name. Yeah, that's a little funny. And here's the problem statement guys, and it appeared in the February long challenge of CodeChef. So Chef has a football team and now he needs to choose a name for the team, right? So there are n words in English that Chef considers to be funny. Right now we are basically given a list of n words. All of them are a few English words consisting of lowercase alphabets that Chef considers to be funny. So now Chef thinks that a good team name should consist of two words such that they are not funny initially, but if we swap the first letters in them, then the resulting words are funny, right? So yeah, so pretty basic. And now we need to tell how many good team names are there. So just to recap, there are list of n words that are funny. Now a good team name is of two words where both of them are not funny, basically not in this list. But if we swap the first letters of both of these words, then both of them are there in the list, right? So they are both of them are funny. So now how many good such pairs of words exist? So yeah, this is the problem, and now let us, for more clarity, have a look at the sample, right? So let's say we are given these two words, suff and mass. So now a good team name could be that we choose muff and sass. Why? Because both of them are not funny, right? Following the above condition. But if I swap these two letters, right? So now this becomes suff and this becomes mass, and both of them are funny, right? So this is a valid team name, and then same goes for these two words as well. This is basically an ordered tuple, right? So this is also funny. So in this case, answer comes out to be 2, right? Then here you can check that no matter what two words you take, there's no way you could get a good team name. So here the answer is 0 since all of them start with G, right? So then this is a little tricky case. So here, let's say you take the words hest and tell. So both of them are not there in the list, right? But if I swap their first letters, right? So now this becomes test and this becomes hell. And test is also there, hell is also there. So this is a valid team name, right? A good team name. And same goes for this reversed tuple as well. So here again the answer comes out to be 2. So let's say I take the same array, hell, bell, best, test, the third sample input, right? So like there's some pre-work that we need to do. So what we can observe is that whenever we are taking two words and swapping their first letter, what's staying constant is the suffix. And what I mean by suffix is the part of the string from the second character till the end, right? And what's being swapped is the first character. So why not just split the strings like this, right? Just cut out the first character and then the remaining string. So from this, convert it to this. And now what we can see is there are repeating suffixes like L and S, right? So we can again convert it into this kind of a structure that L maps to a list of or a set of characters like H and B, right? And EST maps to B and T, denoting that L had H and B as the first character, right? And S had B and T. So after this pre-work, suddenly flow of ideas begins, and a brute force solution that we can clearly see here is that for every pair of suffixes, like these two suffixes, in this case there are only two, but for every pair, INJ or SI and SJ, what I'm going to do is I'm going to take for every pair of letters, right? So SI and SJ, right? I'm going to check for every pair of alphabets, A1 and A2, let's say, right? And what I'm going to check is that if AI is present only in the list of the first suffix and not in the list of the second suffix, right? So what this means is that let's say SI is ELL like here and SJ is EST, and let's say for every pair of characters when I encounter H and T, so what I am going to check if H is present in this list, right, of ELL and not in this list, right? So what this basically means is that hell is a good word, right? Hell is a funny word, but hest is not a funny word, right? What this list denotes is that for if I want to check if best is a funny word, that is it was present in the original array. So what I can simply check if est, if the list of est contains b, right? Like we have formed this structure to have it in O of 1, right? Otherwise, we would have done a full scan of the funny array, right? And then checked if any of them matches. But here we can simply to check if a word is funny, we can simply check if this suffix contains the first character in its list. So when I say that if H is in ELL and it's not in EST, what this means is that hell is a funny word, right? And hest is not a funny word, and the same goes for T. If but this time if test is a funny word and tell is not a funny word, I have a good team name. What? Well, it is Hest and Tell, right? So if like Hest is not a funny word, that is exactly what this conditions tell, that H is present in H is not present in EST but present in ELL, and T is not present in ELL but present in EST. What this means is that initially both of these words are not funny, right? But when we swap, so it becomes test and hell, right? Then both of them become funny. So this is the basic idea. And now let us try to analyze the time complexity and see where we can improve. So this comes out to be big O of n square, right, for every pair of suffixes. And then that for every pair of alphabets comes out to be n square into 26 square, right, for 26 alphabets. A little less than n square, because they would be repeating suffixes, and like here we had only two suffixes but we had four words, right? So the number of suffixes will be a little less, so something less than n square into 26 square, right? But this is going to give us TLE, although we cannot improve this part, but we can definitely try to improve this part, right? Now why? Well, that is because let's say can't I just simply convert this, that if alphabet 1 is only in is only in suffix one's list, right? And alphabet 2 is only in suffix 2, right? That is exactly what we are doing here, right? So what we can do now is that instead of checking for every pair of letters, I could simply now check that for all the letters that are exclusive to S1, right? So S1 exclusive, so the number of these letters multiplied by S2 exclusive, right? Now why? Because I could if there are two letters that are following these conditions, so they are forming a good team name, right? So for every pair of letters, let's say if there are two letters that are only present in the suffix ones list, right? And there are, let's say, three letters that are present in suffix threes list, so all of them will form a combination with each other, right? They are also for following this condition above, right? They are also following this condition, then they are also following this condition, right? So it will also yield a good team name, and same goes for these three as well, right? So if there are two letters that are only in S1 and there are three letters that are only in S2, so all of them when so we can basically multiply 2 into 3, so we'll have six good team names, right? We don't need to tell the team names themselves, we just need to tell how many good team names are there, right? So we can simply increment our answer by 6, right? So now the code should hopefully work. And now let us quickly discuss the implementation. But before that, one thing I wanted to discuss is that let's say after watching this video editorial, you will be able to solve similar questions, right? But what about questions revolving to other CP topics? Because these problems are just the applications of concepts, right? They are not the concepts themselves. So to really get better at problem solving, first we should become conceptually sound and then we should start practicing, right? So that's why if you are unfamiliar with any of the concepts, you must read about it first And for that, instead of just searching all over the net, Unacademy is a one-stop destination for you. So all you have to do is go to Unacademy. There we are teaching you literally every CP topic, and they are being taught by the top coding experts from around the world. So you are being taught by the best. And if you're going for the plus subscription, then you get much additional benefits like individual support, and you get problem sets for each topic, and there are mentors to resolve your doubts even after the class, and they are 6-star and 7-star coders as well. So hurry up guys, just quickly subscribe to Unacademy Plus, because this is the best investment that you can make for a better future. And remember, while registering on Unacademy, they'll ask you for a code. So you could simply type in Bharat 27, right, to register there. And if you are going for the subscription plan, then this will also fetch you a 10% discount on your subscription. So hurry up guys, if you really want to see a quick improvement in yourself and a sharp rating increase, then definitely go for this course. So yeah, this was the problem guys. And all we, just to recap, all we are doing is that for every pair of suffixes, right, what we are going to do is that check the number of characters that are exclusive to this. So basically that will form a funny word with this suffix but not with the other suffix, and the number of characters exclusive to the second suffix, right? And we can simply multiply them. All of them will yield us a good team name, and we can simply keep on incrementing our answer. So yeah, guys, this is the approach. And now let us quickly move on to the code, which is in C++. So here I am just taking the input for the array, right? And then I'm going to maintain a map of a string to a set of characters, MP, and building that exactly as we discussed in our approach, right? So for the substring from the first character till the end, based on zero based indexing. So the remaining part, I'll insert the character, the first character into its set. Then I'm going to go on the loop to check for every pair of suffixes. I'm going to check if they are not the same, right? So we are talking about two different suffixes. Then I'm going to just check the number of common elements in their sets, right? And simply increment the answer by the this is just to check the exclusive characters to one suffix and the exclusive characters to the other suffix, and simply multiplying them, right? And how do I check for the number of common elements? Well, I have defined a function above that uses the set intersection method to find the number of common elements, right? And then it simply returns this. Okay, yeah, so this is the code, guys. Really pretty basic implementation as well. So now let us quickly submit it and hope for an AC. And remember, guys, don't just watch me code the solution. After the video ends, try to code it out yourself to gain the confidence that yes, you were fully able to understand the question. And remember guys, if you get an AC, don't forget to hit the like button and comment down anything inspiring for me. So yes, we got an AC, and this wraps up the video.